When solutions containing magnesium bromide and potassium hydroxide are combined, magnesium hydroxide can precipitate. Magnesium hydroxide can slightly dissolve in the following reaction to produce some magnesium 2+ ions and hydroxide ions. And the KSP for this equilibrium is equal to the concentration of magnesium ions times the concentration of hydroxide ions squared. To determine if precipitation occurs, we need to calculate the reaction quotient, Q, and compare to the value of K. To do that, we will need to find the concentration of magnesium and hydroxide ions. The magnesium ions come from the magnesium bromide, and the hydroxide ions come from the potassium hydroxide. Let's calculate the moles of magnesium ions first. We have 6.55 times 10 to the minus 4 molarity, or moles per liter, of magnesium bromide multiplied by the volume in liters, 0.019. Magnesium bromide dissociates into 1 mole of magnesium 2+ ions for every 1 mole of magnesium bromide, which gives us 1.24 times 10 to the minus 5 moles of Mg2+ ions. We do the same calculation for the hydroxide ions, starting with 3.27 times 10 to the minus 4 moles per liter of potassium hydroxide times 0.011 liters, which is the volume, times 1 mole of hydroxide produced from every 1 mole of potassium hydroxide. We end up with 3.60 times 10 to the minus 6 moles of hydroxide ions. To get the concentration of each ion in the solution, we need the total volume. We had 19 milliliters of magnesium bromide and 11 milliliters of potassium hydroxide, and so we will have 30 milliliters total volume, and we can divide by that volume in liters to get our new concentrations of each ion. 4.15 times 10 to the negative 4th molar magnesium. And we do the same for the hydroxide. And we get 1.20 times 10 to the minus 4 molar hydroxide ions. Now we're ready to calculate our reaction quotient using the ion concentrations. For magnesium, 4.15 times 10 to the minus 4, and hydroxide, 1.20 times 10 to the minus 4 squared. And Q will equal 5.98 times 10 to the minus 12. Let's compare the value of QSP to our KSP given in the problem, 1.5 times 10 to the minus 11. We can see that QSP is less than KSP, which tells us that we are product favored and that no precipitation occurs.